question number 4 for our test, and it's going to be all about Nuromol. And let's read it. Determine the total number of ibuprofen and paracetamol molecules present in each tablet of, Nuromol. Now, what does each tablet of Nuromol contain? You can see here it's got 200 milligrams of ibuprofen, and paracetamol is this. So what I'm going to start with, I'm going to start by finding the number of moles of ibuprofen, and that's going to be equal to 0.2, because my mass has to change into grams, remember, 0.2 grams. That's divided by my molar mass. My molar mass comes from the molecular formulas over here, and I'm going to work out what that is. So remember, carbon is 12, so 13 times 12 gives me 156. 156 plus hydrogen's 1, so it's plus 18, and oxygen is 16, so 2 of those is 32. So that plus 18 plus 32 gives me a molar mass of 206. So that is going to be equal to 0.2 divided by 206 gives me 9.71 times 10 to the power of negative 4. Always go with 3, but negative 4 mole. My number of moles of paracetamol equals 0.5 divided by the molar mass of that. So let's have a look at what that is. It's 8 times 12, so it's 8 times 12. That's 96 plus 9 plus molar mass of nitrogen, 14, plus 32 for 2 oxygens. So 96 plus 9 plus 14 plus 32 gives me a molar mass of 151. So 0.5 divided by 151 gives me 3.31 times 10 to the power of negative 3 mole. Now, I stuffed up this when I actually did the solutions to this on Gradescope, but the question says the total number of ibuprofen molecules. So not only do I need to find my mole, I then need to find capital N of ibuprofen and capital N of paracetamol. And that means I need to do N times Na equals N times Na, where I needed my number of moles times by what a mole is, which is 6.02. So it's 9.71 times 10 to the power of negative 4 times 6.02 times 10 to the power of 23. And this one will be 3.31 times 10 to the power of negative 3 times 6.02 times 10 to the power of negative 23. Anyway, let's have a look at how I do that in my calculator. I've got this number already, so I'm going to start with this one. So I'm going to take this number, I'm going to times that by 6.02 times 10 to the power of 23 equals, and I've got 1.99 times 10 to the power of 21 molecules of paracetamol in one tablet. I've got that many molecules of paracetamol, a massive number. And then I'm going to go back and try and do this one. But again, I'm going to try and get my exact number. So I'm going to quickly go back to where I got that exact number. 0.2 divided by 206 equals my exact number. And then I'm going to times that by what a mole is, which is times 6.02 times 10 to the power of 23. And that gives me 5.845 times 10 to the power of 20. And that's molecules of ibuprofen and paracetamol. You can see my notation is quite good here because I'm showing you what I've calculated next to it. I haven't just got random numbers here. I've got numbers, but I've attached that to notation as to what those numbers are talking about. Moving on to question B. So, aspirin is another molecule widely used as a painkiller. It consists of 60 blah blah blah, empirical formula time. So I need carbon, oxygen, and hydrogen. And I've got 60 grams, I've got 35.5 grams, and I've got the rest hydrogen. So 100 take away 60, take away 35.5 gives me 4.5 hydrogen. So therefore, I go through and divide by my moles. So that's step 1 is my mass, number of moles is step 2, so divide that by 12, divide that by 16, divide that by 1. So 60 divided by 12 is 5 mole, 5 divided by 1 is 4.5 mole, and then I need to do some calculation here. 35.5 divided by 12 gives me, divided by 16. 35.5 divided by 16 gives me 2.21. Yep, that's fine. Now, step 3 is to get these to whole numbers. This is too high to round because I got 0.2. So what I'm going to need to do is I'm going to need to times this by 5 to get to a whole number. Actually, it's 0.22 there. Alrighty. So let's have a look at what we got to do. So let's times it by 5. Divide by my lowest numbers. Step 3 is divide by lowest numbers. Didn't make sense to me. I was going to get a massive number. So divide by 2.22, divide by 2.22, divide by 2.22. That gives me 1 here. 4.5 divided by 2.22 gives me 2, and 5 divided by 2.22 gives me 2.25. Now I need a whole number ratio. So my whole number ratio here, I'm going to times everything by 4, and that's going to give me C something O2 and H8. So what is 2.25 times by 4 gets me up to 9. So my empirical formula is C9O2H8. And that's my empirical formula for aspirin. Going through that system of what's my mass, what's my mole, divide by the lowest number of mole, and then get to a whole number once I've done that. So step 4 is where I've got 0.25. To get that up to a whole number, I need to multiply through by 4. Anyway, lastly, an extract from a mass spectrum shows the molar mass of aspirin is this. What is the molecular formula? So again, my empirical... my phone ran out of space again. But anyway, I'm on to part C now, and let's just see where we're up to. I don't know where I got to with explaining this, but still. We've got the molar mass of aspirin is 180 grams. What's my molecular formula? So I go through the same process I did with the last question that asked me the same type of question here. My empirical formula is this. My molecular formula has a mass of 180 grams. So what is my molar mass of my empirical formula? I've got 9 times 12 equals 9 times 12 equals 118 plus my 32 from my 2 oxygens. Do I have 2 oxygens? No. I've got 4 oxygens. I stuffed this up. That's 4. So that's 4 oxygen. All right, let's try this again. Hopefully I've deleted enough for this video. But it's 4 oxygens because I had this as being 1, and I had to times through by 4. So that should be a 4 there. But anyway, my empirical formula and my molecular formula. My empirical formula mass is 180, which happens to be the same mass as my molecular formula. I'm doing the same process as I did last question, which I think was question number 3. Exactly. So therefore, that is how you do part C there, where you start off by looking at what is my empirical formula mass, and then I work out what multiple of that is my molecular formula, which it just so happens that they both end up being 180. And that's the answer.